Hello, in this video I'm going to teach you how to check if a vector field is conservative in 3D, and if it's conservative, how to find its potential function. First, you need to know the curl of a vector field. Curl of f, first of all, if we have f equal mi plus ng plus b key or m n b. So curl of f is the same as nabla cross f. This operator here is d by dx, d by dy, d by dz. So this will be I g key, d by dx, d by dy, d by dz, m n b. So now this will be this determinant. So now this will be by minus nz I mz minus bx g nx minus my k. So by minus nz I plus mz minus bx g plus nx minus my k. If curl f equals 0, f is irrotational and in the same time conservative. So to check if a vector field is conservative, you need to check this zero vector. You need to check if curl of f is 0. So curl of f is 0 when this is 0 and this is 0 and this is 0. So this means by equal nz, mz equal bx, nx equal my. So if this true, f is conservative. To remember this formula or this condition, you can start by, you have the vector mnp, so you can start by writing m, then n, then b, and m here n, b, m equal, start with y, and after y z, and then x. here start with x, y, z. Or you can remember it using, instead of writing all this determinant, you just dx, dy, dz, m, n, b, and then you need by equal nz, you need bx equal mz, and you need nx equal my. So from here, or if you're able to remember this condition, it will be fine. Now let's try to solve some example. Next thing we will do, if f is conservative, we need to find here if f is conservative. This means there exists phi x, y, z such that f equal gradient of phi, which is phi x, phi y, phi z, which is m n b. So if f is conservative, we need to find phi, which is called potential function. First, we will start by examples, check if f is conservative, and if f is conservative, we will calculate phi. So first example, determine if x, y, z equal y square, this m, 2xy plus e to the power 3z, this n, 3y e to the power 3z, this b, is conservative. To check if f is conservative, we will apply our condition. So our condition says that from here we'll start by my equal, if you differentiate this according to y, or with respect to y, it will be 2y. Nx equal, if you differentiate this term with respect to x, it will be, this will be 0 and this will be 2y. So this is good. Second part, we need to check if nz equal by. So nz equal by. To check to evaluate nz, here we will differentiate this according to z. This will be 0 and e to the power 3z will be 3e to the power 3z. So this will be 3e to the power 3z. by equal, differentiated with respect to y, it will be, this is 3 is constant, e to the power 3z is constant with respect to y, so this will be 1, so it will be 3e to the power 3z. So this is also true. Last condition, bx equal mz. What is bx? Differentiate this according with respect to x will be 0. Differentiate m with respect to z will be 0. So from these conditions, f is conservative. Now we need to find phi such that f equal gradient phi. As I said now, m equal y square is phi x, n equal 2xy plus e to the power 3x 3z equal phi y, and b equal 3y to the e to the power 3z equal phi z. So we will start by integrating phi x according or with respect to x. So it will give us phi x y z. Integrate this with respect to x will give you xy square plus function of yz. You know that if you differentiate this function with respect to x, this will give you y square and this will give you 0, because this is function of y and z, meaning that it's constant with respect to x. Now, if we differentiate this function with respect to y, it gives us phi y. So phi y will equal, differentiate according to or with respect to y will give you 2xy plus differentiate this function with respect to y will give you fy. Note that this function is function of two variables, so when you differentiate with respect to y, it will be the partial derivative. So fy yz. Phi y must be equal n, so this will be equal to xy plus e to the power 3z. So from here we can find that fy equal e to the power 3z. So fy equal e to the power 3z. So now if we integrate with respect to y, fyz equal y e to the power 3z. Don't forget that the constant, which is function of z. Note that if you differentiate this function with respect to y, this will give you e to the power 3z plus 0, because this is function of just z. So when you differentiate this with respect to y, will give you 0. Now we will substitute this in our main function. So phi xyz equal xy square plus fyz, which is y e to the power 3z plus gz. Now we need to find gz, so we will differentiate this function with respect to z. Phi z xy z equal, when you differentiate this with respect to z, give you 0. When you differentiate this with respect to z, will give you 3y e to the power 3z and this will give you g dash z. Phi z is the same as b, so 3y e to the power 3z. From here we can find that g dash z equal 0. So g dash z equal 0. This means that gz equal constant. So from here phi x y z equal xy square plus y e to the power 3z plus gz, which is constant. You can put this constant 0 or leave it like this. If you try to calculate m, which is phi x, n, which is phi y, b, which is phi z, from this phi you will find the same three functions here. You can check now. Next example here, we have f, this is m, this is n, this is b. We need to check if f is conservative, so we will apply the condition. So the condition is my equal nx and nz equal by and bx equal mz. Let's calculate my. Differentiate this with respect to y will give you ex is constant, cosine y, when you differentiate it with respect to y, it will be negative sine y. So this will give you negative e to the power x sine y, and yz will give you z. Nx, when you differentiate n with respect to x, will give you z minus e to the power x. There is something missing here, I think. Yeah, I think. What is the function e to the power x cosine? 1 moment. Yeah. This is xz minus e to the power x sine y. Sorry for this. Sine y and this b. Okay, in this case, when we differentiate n with respect to x, will give you z from first term minus here sin y is constant. When you differentiate e to the power x with respect to x, will give you e to the power x, so this will be e to the power x sine y. So from here you can find that my equal nx. Second condition, nz, differentiate n with respect to z. First term will give you x, second term will give you 0. So this will be x by, when you differentiate b with respect to y, first term will give you x and second term will give you 0. Also nz equal by. Third condition, bx, when you differentiate this term with respect to x, will give you y. When you differentiate m with respect to z, first term will give you 0, second term will give you y. So also bx equal mz. So now f is conservative, and we need to calculate, or find a potential function phi such that f equal gradient of phi. So here m equal e to the power x cosine y plus yz equal phi x, n which is equal to xz minus e to the power x sine y equal phi y, and b which is equal xy plus z is phi z. As I told you before, we can start with m and integrate phi x with respect to x will give you phi, and then going in the same way. You can start with n and integrate phi y with respect to y, and then you will have function. We can do as I told you here. We start by integrating phi x, so it will give us some term plus function of yz. If you, instead of integrating phi x with respect to x, you will integrate phi y with respect to y, it will give you some term which is dependent on this plus function of x and z, and then you will calculate phi x and go in the same steps. So you can start from any of those three terms. Let's start, for example, from phi z, and you can do it from phi x2. If we start from phi z and integrate this term with respect to z, so phi x y z will give you, this will give you x y z plus half z square plus function of x y. Then we will calculate phi x, differentiate with respect to x, will give you yz from first term. This will give you 0, and this will give you the partial derivative of f with respect to x. Now this phi x is equal to m, which is e to the power x cosine y plus yz. From here we can deduce that fx is equal to e to the power x cosine y. So fx xy equal e to the power x cosine y. If we integrate this function with respect to x, will give us fxy equal Note that you integrate here with respect to x, so this is constant. So will give you e to the power x cosine y plus some function of y. Now, if we substitute fxy here, phi x y z will be xyz plus half z square plus e to the power x cosine y plus g of y. Now, if we differentiate phi with respect to y, will give us, this will give us xz, this will be 0, and this will give us negative e to the power x sine y. And this will give us g dash y. Now, phi y is the same as n, which is xz minus e to the power x sine y. From here we can deduce that g dash y equal 0. So g dash y equal 0, so gy equal constant, which is c. So phi in this case will be xyz plus half z square plus e to the power x cosine y, and gy is constant, plus c. If you put here c equals 0, you find one potential function. This is called the family of potential functions. Every potential function differs from the other by this constant. So one potential function is when c equal 0. Third example, determine if f equal 2x minus 3 z cosine z is conservative. If it is, find a potential function phi such that f equal gradient of phi. We will start by our condition. my nx nz by bx mz. My, first this m and this n and this b. My, we will differentiate this with respect to y, so we'll give you 0. nx, we will differentiate this with respect to x, will give you 0. So my equal nx. Next, nz. We will differentiate this with respect to z, will give you 1. py, we will differentiate this with respect to y, will give you 0. So now this condition is not satisfied, so you cannot, you don't need to continue to check if bx equal mz. So here, since nz don't equal py, so curl f don't equal 0 and f is not conservative. If f is not conservative, you cannot find phi such that gradient of phi equal f. I hope you understand how to check if a vector field in 3 dimensions is conservative, and if it's conservative, how to calculate or find its potential function. Now, last thing we will see in this video, for the last video we say that in 2 dimensions, if f equal m xy, m xy, n xy, f is conservative if my equal nx. This condition come from this condition come from curl f equal 0. So in general, when curl f equals 0 in 2D or 3D, your vector field is conservative, because here we are in 2D, so the z component will be 0. So f x y z will be m and n and 0. So if you apply here, curl of f will be equal I g k d by dx d by dy d by dz m n 0. So now if you try to calculate this curl, you will find that here I will be d by dy 0, okay? D by dy 0 will give you 0 minus d by dz n. But note that n, we need to write it like this to understand. mxy nxy 0. Again, I component d by dy 0 is equal 0 minus d by dz n xy. Note that n is a function of xy, so when you differentiate it with respect to z, will give you 0. So this component will be 0. And also for g, d by dx 0 with 0, d by dz mxy will give you 0, because this is function of xy, not a function of z. So the only term here is this, which is d by dx n, so this will be nx, minus d by dy m, which is my key. So curl f equals 0 when this term equals 0, when nx equal my, which is the same condition that we took last video. So my equal nx comes from this fact that f is conservative when kernel of f is 0. I hope you understand now why we took in the last video the condition nx equal my give you that f is conservative. If you have any comment, any question, you can write it in comments. And if you want me to explain specific concepts or specific questions, you can write it in comments and I will do this. Good luck and see you in next videos.